Hello everyone, my name is Mrs. Mwangi and I'm here to teach you about effects of an electric current on substances. This is a topic that we learn in Form 2 and it is one of the topics that is also continued in Form 4 where we look deeper into the electrolysis part of this. By the end of this lesson, we have a few objectives that we are supposed to meet, and we are supposed to have the following as our major objectives. Number one, by the end of this lesson, the learner should be able to, number one, define conductors and non-conductors. Number two, the learner should be able to identify particles that are responsible for electrical conductivity. The third objective, the learner should be able to identify or explain why graphite, being a non-metal, conducts electricity. And finally, the learner should be able to draw a setup that shows simple electrolysis. So these are our few objectives that we are going to meet in this lesson. So for us to understand or be able to define what conductors and non-conductors are, we are supposed to list down, or we are going to list down a few solids here, and we are going to carry out some tests that will show us or that will help us identify and classify conductors and non-conductors. So we are going to have a list of items here. We will start with aluminium, magnesium. We are also going to have zinc, graphite, wood, sugar, sulfur, sodium chloride, we are also going to have lead chloride. These are just a few examples. We can have more than this. Now here we are going to draw, we are going to have a setup that we will use to So this is the simple setup that we shall use to investigate the electrical conductivity, to investigate the electroconductivity of these solids that we have listed here. Now we are going to have a bulb. A bulb will help us identify in this way. Whenever we put our test sample here, or our solid, whenever we put our solid or our sample on the crocodile clips, if that substance conducts electricity, then the bulb will light. But if that substance or that solid does not conduct electricity, the bulb will not light. So we are going to put various solids, including sodium chloride, lead chloride, aluminium, magnesium, zinc, graphite, wood, sugar, and sulfur. And since this is a theoretical, it's a theory lesson, when you do it practically, we will discover that when we put zinc, the bulb will light. When we also put aluminium, the bulb will also light. When we put graphite, the bulb will light. And when we also put magnesium, the bulb will light. On the other hand, when we put sugar, the bulb would not light. When we put wood, the bulb will not light. When we put sodium chloride, the bulb will not light. And also when we put lead chloride, the bulb would also not light. Now, these substances that are in solid state, and they allow an electric current to go through. They are the ones that we refer to as conductors. And these solid substances that do not allow electric current to pass through them are the ones that we call or we refer to as non-conductors. Now, this setup is the one that helps us identify or classify substances as conductors and non-conductors. Whenever the bulb lights, when the switch is closed, when we close the switch here and the bulb lights, that substance we classify it as a conductor. When we put a substance like sugar and the bulb will not light, that substance will classify it as a conductor, as a non-conductor. So these are the two classifications of solid substances when it comes to electrical conductivity. Remember, we are insisting on the solid substances. Some of these substances, an example of sodium chloride and lead chloride, and even lead bromide that we have not included here, will conduct electricity in a different state. Remember, we say that matter exists in three states. We have the solids, we have the liquids, and we also have the gases. So in a different state, sodium chloride and lead chloride will conduct electricity. So having classified solids as conductors and non-conductors, the other question that we need to answer is, or the other question that we need to explain is, how do you define the term conductor? How do you define the term non-conductor? Now that we have classified substances into conductors and non-conductors, how do you define a conductor and how do you define a non-conductor? So we start by defining what conductors are. Conductors or conductor, they can be many, so we can put an S there. So these we define as substances that allow electric current to pass through them, specifically in solid state, are the ones that are referred to as conductors. Substances that allow electric current to pass through them in solid state, they are referred to as conductors. What about non-conductors? Conductors, if there are many. Now, a non-conductor is a solid substance that does not allow electric current to pass through them, or if it is one, through it. So that is how you define conductors and non-conductors. That conductors are substances that allow electric current to pass through them in solid state, and non-conductors are solid substances that do not allow electric current to pass through them. Now, the other thing we ask ourselves is, if we are classifying substances as conductors and non-conductors, what is present in the conductors and absent in the non-conductors? So, in solids that allow electric current to pass through them, or solids that conduct electricity, have mobile electrons. Or we can use another term. Instead of saying that they are mobile, we say that they are delocalized. We talk of electrons that are delocalized. So in conductors, we have got delocalized electrons, which are absent in non-conductors. So non-conductors do not have delocalized electrons. They do not have free electrons in their structure. But conductors do have delocalized electrons. So we realize that graphite is a non-metal, and from our previous lessons, you know that graphite is a non-metal and it conducts electricity. So why does it conduct electricity and other non-metals like sulfur does not conduct electricity? Something like chlorine will not conduct electricity. Something sugar will not conduct electricity, but sulfur is a non-metal and it conducts electricity. So in the structure of graphite, we know that carbon Graphite is an allotrope of carbon. Graphite is an allotrope of carbon, and it has got 4 electrons. It has 4 electrons in its outermost energy level. This means that these 4 electrons that are present in graphite, not all of them are used for bonding. So graphite will use 3 electrons. Graphite will use 3 electrons for bonding, and 1 electron is left free. And this is the one that is responsible for electrical conductivity in graphite. And it qualifies now as one of the conductors because it has got a free or a delocalized electron. It has got a free or it has got a delocalized electron in its structure, and this qualifies it as a conductor. This qualifies it as a conductor. So in other words, we are saying that if a solid substance will conduct electricity, must have delocalized electrons. If a solid substance does not conduct electricity, then the delocalized electrons are not present. The delocalized electrons are not present. Now, the conductors, some of them are better conductors than others. Conductors others are better conductors than others. What makes a solid substance a better conductor than the other? It is the number of delocalized electrons in that substance. For example, if you take sodium metal, compare its conductivity with another solid or another metal like magnesium. Sodium metal, being in group 1, has got 1 delocalized electron. Its configuration is 281. That of magnesium is 282, being in group 2. So this shows us that sodium metal has got only 1 delocalized electron, whereas magnesium has got 2 delocalized electrons. So when you compare the conductivity of the two solids, magnesium would be a better conductor than sodium because of the high number of delocalized electrons in its structure. We can also compare this to another element like aluminium. Aluminium, which has got 3 electrons in its structure, because its configuration is 283, it has got 3 delocalized electrons in its structure. This one shows that this will be a superior conductor compared to sodium and magnesium. So aluminium is a better conductor because it has got more delocalized electrons. It has got more delocalized electrons.